welcome back to Understanding Angles Part 3. We're going to look at some protractor misconceptions and also problem solving with unknown angle measures. All right, so remember all those different ways that we learn about what an angle actually is, including one of those being as part of a turn and part of a circle. So, Emily, often our protractors, traditionally, it's just that semicircle, right?
Which is definitely a misconception for a lot of our students, so it'll help them to see it in a full circle.
Yeah, so a lot of students would benefit from first starting with that full circle protractor because you can really see now that that angle is a turn. And really, you could start anywhere on the circle, but we know that'd make it difficult to find the total turn, so we want to start at that 0.
Joe, could you bring the wedges that we talked about in the first session back to this as well?
Yep. We worked with those wedges concretely. It's now in our brains of how wedges are really part of an angle, so you can even now picture that wedge as being on there. You could even break out some of those wedges and stick them on that circle and measure what their turn would be, what that wedge would be in degrees. So if you are starting with that semicircle, maybe break out some of those full circle protractors for some of our students. And now we see our semicircle traditional protractor. And most protractors are going to have 2 scales on them, an inner scale and an outer scale. Emily,
this is a huge misconception.
Yeah, I was just going to ask, do you ever have any issues with kids picking the wrong scale?
I do, but I'm really excited this time using those wedges from session 1. I think, and the benchmark angles, I think my students will have a better understanding as to which scale to use because of the time we spent with that.
Exactly. You know how students, we want them to use estimation to determine reasonable sums, reasonable differences, products. We're going to do that too in measuring. It's no different. So we, in the beginning, way back in part 1, we started classifying angles based on a right angle, right, acute, obtuse, without even measuring. We just wanted them to kind of eyeball it and estimate which of those that would be.
So visually here, I could see that this angle is going to be less than 90 degrees because it is less than it's smaller than a right angle.
Yeah, it's an acute, it's smaller than right. It's got to be less than 90. So now let's bring in, we measure it.
Then my students would know that it would not be 110 degrees because that would not make sense, or I'm sorry, 120 degrees, that would not make sense because the angle is smaller than a right angle.
There you go. So reasonable. 120 degrees would not be reasonable for an acute angle.
This makes sense as to why we started with the estimation using angles.
Same thing here. This one's obtuse. Saying that is 50 degrees would not make sense. It would not be reasonable. So we're bringing it all back to why we started where we started. Another misconception a lot of students have is that whole name of a right angle, that idea of a right angle, that it's the orientation, it's the way it opens up, that it has to open up to the right. So these other angles, they might not think that they're right. They might even call them a left angle.
Joe, we've introduced our folks to a tool that we could use to help with these misconceptions and showing the different representations of angles. The concept card is a great tool to use to help with that.
Even just making sure that we're exposing students to the angles oriented in different directions too. Because in real life, we're going to have our angles all over the place.
Something I struggled with in high school, and I think it's because I didn't use wedges or learn conceptually about what an angle or a measurement is with angles.
Yep, so here now we're looking at problem solving with finding missing angle measures. Really, we could have started doing this with our wedges concretely. So I brought back some angle eggs. I made an angle here. Do you see a benchmark angle on there?
I do. I see. I'm thinking probably if we're using wedges.
Yeah, if we're using wedges.
I'm thinking that perhaps it would be approximately 6 wedges.
Yeah, so where the yellow and green, they're making a straight line, right? A straight angle. Those were, if we remember back, those were 6 wedges. So what if I told you that 2 wedges fit here with the yellow and purple?
And knowing what I know about a straight angle and that 2 wedges fit there, that the other side would be 4 wedges.
There you go. So working with even simpler numbers with these wedges, We're just building that idea that we can look for those missing angle measures and using those benchmark angles. We could have had a right angle on there, which would have been 3 wedges. We could work with that.
Again, conceptually taking a non-standard unit and connecting it to what they're going to do with actual angle measurements.
Exactly. And then we're going to go in, they can solve problems with circles, knowing 360 degrees, working in squares, knowing those are 90 degrees. How could we find other missing angles? And ultimately finishing in this most abstract of application with equations with missing variables.
I could have really used you as my high school geometry teacher, Joe.
Yeah, this is kind of what your high school geometry would look like, right? But our 4th graders are able to do it if we followed that progression of work with angles. And we can now see our nice journey through angles from our concrete islands to our representational islands and to our abstract, and always making those connections, jumping back and forth.
I think that's the important part. And we talked about that using connecting the protractor back to the angle wedges again. So as you can see, going back and forth through the different ways of thinking.
So all that work that we saw in part 1 and part 2 manifests itself in this nice geometry abstract kind of condition that you're looking at, right? All right, so we hope that you found all of these angle videos very helpful, and your students will benefit from that as well.
Thanks for joining us today.